In the last lecture, we discussed about what is the meaning of sequence, series, infinite series, finite and infinite series. Then what are the three different natures of the series, like convergent series, divergent series, and oscillatory series. And also we have seen that what are the properties of a infinite series. Now, let us take some examples so that what are the topics we studied in the previous lecture can be applied to the given examples. Now, take the convergence of the series 1 upon m plus 1 into m plus 2 plus 1 upon m plus 2 plus m plus 3 plus 1 upon m plus 3 plus m plus 4 and so on. We have to check that this series is convergent or not. The nth term of the given series is given by un is equal to 1 upon m plus n into m plus n plus 1. Just look here. There, this is the 1, first term 1, second term 2, third term 3. So nth term should be n. In the same manner, the first term is 2, second term is 3, third term is 4, fourth term is 5th. So similarly, the nth term will be n plus 1. Therefore, we are writing un means nth term of the given series, which is equal to 1 upon m plus n into m plus n plus 1. Let us try to do the partial fraction. And if we do the partial fraction, this expression can be written as 1 upon m plus n minus 1 upon m plus n plus 1. Now it can be easily checked that the value of this thing, this value is just equal to this one. So let us take the LCM of m plus n and m plus n plus 1. So this is nothing but m plus n into m plus n plus 1. If we divide m plus n into m plus n plus 1 by m plus n, we are getting m plus n plus 1, and that should be multiplied with the 1. So m plus n plus 1 minus, it is m plus n. If you again simplify it, m plus n plus 1 minus m minus n whole divided by m plus n into m plus n minus 1. M plus n minus n plus n minus n will cancel. And now we have 1 upon m plus n into m plus n minus 1. That's why the value of this value is equal to 1 upon m plus n into m plus n plus 1. So we can write down, this can be written in this form. Now consider the sum of first n terms. Sn is equal to un, u1 plus u2 plus u3 up to un. Now let us put the value of, if we want to find u1, we have to first put what is the first term, 1 upon m plus 1 into m plus 2, plus second terms 1 upon m plus 2 into m plus 3. Third term is 1 upon m plus 3 into m plus 4. And similarly, if we write down the nth term, so the nth term is nothing but 1 upon m plus n into m plus n plus 1. Now, since we are able to write down 1 upon m plus n into m plus n plus 1 can be written in this manner. So similarly, we can write down 1 upon m plus 1, 1 upon m plus 1 into m plus 2 can be written as 1 upon m plus 1 minus 1 upon m plus 2. Similarly, 1 upon m plus 2 into m plus 3 can be written as 1 upon m plus 2 minus m plus 3, and so on. Similarly, the last term can be written as 1 upon m plus n plus 1 upon m plus n minus 1. Oh, means it means the previous term is 1 upon m plus n minus 1 minus 1 upon m plus n. And the last term can be written as 1 upon m plus n minus 1 upon m plus n plus 1. If we simplify all this term, so that this term and this term will cancel. So all term will be cancelled except the first term and the last term. So we have only the two terms remaining. The remaining term will be cancelled out. So this is what it is, 1 upon m plus n minus 1 upon m plus n plus 1. Now consider, we want to find out, this is the sum of first n term of the given series. So we will find out what is the limit of this Sn. Let us find out the limit of Sn. So limit of Sn is equal to 1 upon m plus 1 minus 1 upon m plus n plus 1. And if we simplify, if we put the limit as n tending to infinity, this is free from n, so we have the same value, 1 upon m plus 1. And here if we put n equal to infinity, something upon infinity is 0. Therefore, the second term will ultimately become 0. Now, the limit of Sn from when n tending to infinity, which is equal to 1 upon n plus 1, which is a finite quantity. So since the limit of Sn when n tending to infinity is finite quantity, therefore, the given series is convergent. Thank you, dear friends.